Welcome back everyone. In last 14 videos, we have learned all the theory required to build AI applications. We learned what AI is, LLMs, how ChatGPT works internally, tokens, embeddings, vector databases, semantic search, RAG, AI agents, function calling, and how Java communicates with OpenAI. Today we will write our first AI application. Before watching further, ask yourself this question. How many lines of Java code do you think are needed to talk to ChatGPT? 100, 500, or maybe just 5? You will be surprised. Before writing code, let's understand our goal. Imagine we are creating an application for our company. The application has a simple REST API called slash chat. A client sends a question. For example, explain Java streams. Our Spring Boot application receives that request. Instead of answering itself, it forwards the question to Spring AI. Spring AI communicates with OpenAI. The AI generates the answer. The answer comes back to our application. Finally, our REST API returns that answer to the user. Notice something important. Our application doesn't contain the AI model, it only communicates with it. This is exactly the same way your application communicates with payment gateways, Google Maps, weather APIs. The only difference is that the response is generated intelligently instead of being fetched from a database. If I replace OpenAI with another provider like Anthropic or Google Gemini, do I need to rewrite my entire Spring Boot application? The answer is no. Only the AI provider changes. The architecture remains the same. Many beginners think AI projects have huge project structures. Actually, they don't. Let's understand each file here. First, we have our controller. The controller receives HTTP requests, exactly like every Spring Boot application you have ever written. Second, we have the service. This is where our AI logic will live. Why not put AI code inside the controller? Because controllers should remain thin. Controllers' work is only to receive requests. Services perform business logic. The third file is application.properties. The file contains configuration, things like API key, model name, temperature. Notice that we are not hard coding these values inside Java classes. Configuration should always stay outside the code. Finally, we have pom.xml. This tells Maven which libraries our application needs. One of those libraries is Spring AI. That's it. Now, dependencies. The first dependency is Spring Web. You have probably used this in almost every Spring Boot project. It gives us controllers, REST API, JSON handling, and embedded Tomcat. Nothing new here. The second dependency is the interesting one, Spring AI. Many developers think this dependency contains ChatGPT. It doesn't. Spring AI is simply a Java client. Think about REST template. REST template doesn't contain the weather API. It only knows how to call it. Similarly, Spring AI doesn't contain ChatGPT versions. It simply knows how to communicate with OpenAI using HTTPS. This is a very important distinction. The intelligence lives on OpenAI's servers, not inside your application. Now let's configure our application. The first property is the API key. Think of the API key as your identity card. Whenever your application sends a request to OpenAI, this key tells OpenAI who you are. Without it, OpenAI rejects the request. Never hardcode your API key inside Java classes. Never upload it to GitHub. In production, store it securely using environment variables or a secret manager. Next comes the model. This tells OpenAI which language model should answer your request. You might choose a smaller, faster model for simple tasks or a more capable model for complex reasoning. The exact model names may evolve over time, so always check the current provider documentation before choosing one. Finally, we have temperature. Temperature controls randomness. Imagine asking AI, write a birthday wish. At a low temperature, you will get a straightforward, predictable message. At a higher temperature, the response becomes more creative and varied. A common misconception is that higher temperature makes the AI smarter. It doesn't. It simply makes the output less deterministic. For applications like banking, legal, or healthcare, you will generally prefer lower temperature values because consistency is important. For creative writing or marketing content, a higher temperature can produce more varied and imaginative responses. So far, our project is configured. We have the dependencies, we have the API key. Now let's write our first Java class. The first Java class we will create is the controller. Now here's the question. Why do we even need a controller? Remember, our users don't directly call OpenAI. They call our application. Think about applications like Amazon, Swiggy, or Flipkart. When you search for a project, your browser never talks directly to a database. Instead, it sends an HTTP request to a backend application. Exactly the same thing happens here. Instead of a product search, the user is asking an AI question. So, our Spring Boot application needs an entry point to receive that request. That entry point is called the controller. Notice something interesting. There is absolutely nothing AI specific here. This is the same controller you have been writing in Spring Boot for years. AI doesn't replace Spring Boot architecture, it fits into it. Interview question could be, why should AI request come through a controller instead of directly calling OpenAI from the front end? Answer is to protect API key, to add authentication, to validate request, log request, apply business rules, prevent misuse. Our controller shouldn't know how AI works. Its responsibility is simple. Receive the request, forward it to the service, return the response. This follows one of the most important principles in software engineering: separation of concerns. Let's understand this with an example. Imagine a restaurant. The waiter takes your order. The chef cooks the food. The waiter brings the food back. Does the waiter know how to cook? No. Similarly, our controller doesn't know anything about OpenAI. It simply forwards the request. The service becomes our chef. That's where all the AI logic lives. This separation makes the application easier to test, maintain, and extend. Tomorrow, if we decide to switch from OpenAI to another AI provider, most of the changes will be inside the service, not the controller. Many beginners write everything inside the controller because the project is small. Avoid this habit. Small projects become large projects. Good architecture should scale always. Now we are creating our first AI endpoint. Let's read this method like the Spring framework does. The first line is post mapping slash chat. This tells Spring Boot whenever someone sends an HTTP post request to chat, execute this method. Simple. The second line contains at the rate request body. This tells Spring take whatever JSON the user sends and give it to this method. For example, the client might send question explain Java streams in JSON format. Spring converts that JSON into a Java value before our method runs. Notice something important. Our controller still doesn't call OpenAI. It simply forwards the question to the service. Again, the controller is acting like a receptionist. It doesn't solve the problem. It routes the request to the correct place. If tomorrow someone asks, explain Kubernetes, will we create another API? No. The same endpoint will work. Only the question changes. Now we have reached the heart of our application. This is where AI actually begins. The service layer is responsible for business logic. In our case, the business logic is take the user's question, send it to OpenAI, receive the response, return it. Notice this object, ChatClient. This is one of the most important classes in Spring AI. Many developers think ChatClient is an AI model. It is not. Think of ChatClient as a smart messenger. Imagine you want to send a letter. You don't travel across the world to deliver it yourself. Instead, you hand the letter to a courier company. The courier knows how to package it, transport it, and deliver it. Similarly, chat client knows how to create the HTTP request, where to send, how to include your API key, how to read the JSON response, and how to return it in a Java friendly way. Without chat client, we would have to write all of that ourselves using an HTTP client. What is chat client? A Spring AI abstraction that simplifies communication with an AI model. It builds the request, sends it to the configured AI provider, receives the response, and exposes a fluent Java API. Now let's understand how this object is created. Notice that we are not writing new chat client. Instead, Spring gives us chat client.builder. Why? Because Spring already knows how to configure it. Remember the properties file we created? It contains API key, model, temperature. Spring reads all those configuration values automatically. Then it creates a builder that's already configured. When we call builder.build, Spring creates a ready to use chat client. This is one of the biggest advantages of using Spring AI. Imagine if we are not using it, we would need to create a HTTP client, build JSON manually, add authorization headers, handle serialization, parse the JSON response. Spring AI hides all of that complexity. Instead of writing 100 lines of networking code, we write just a few lines focused on our business logic. Congratulations! So, we have reached the most important line of code in this entire project. If you understand these four methods, you understand how Spring AI communicates with OpenAI. Let's read this code exactly like Java executes it. First, we have a chat client. Remember from the previous slide, this chat client already knows our API key, which AI model to use, temperature, and other configurations. Now we are asking it to start an AI request. Notice here there is no URL, no HTTP client, no JSON, authorization headers, there is no API key inside this code. Spring AI hides all those details. Our job is simply to describe what we want. Spring AI takes care of how it is done. This is one of the biggest advantages of using Spring AI. If Spring AI hides all the networking code, then where does the HTTPS request happen? We will discover that in next few slides. The first method that we call is prompt. But what exactly is a prompt? Many beginners think a prompt simply means a question. Actually, a prompt is much more than that. A prompt is the complete instruction set to the AI. Imagine you open ChatGPT, you start a new chat, nothing has been typed yet, but the conversation now exists. That's exactly what prompt is doing. It creates a new prompt object. Think of it as opening a blank document before writing a letter. At this stage, nothing has been sent to OpenAI. No network call has happened. We are simply preparing the request. This is important. Many developers mistakenly believe prompt immediately calls ChatGPT. It doesn't. We are still building the request. Now our prompt is empty. The next step is to tell the AI what the user wants. That's what user question does. Suppose the browser sends explain Java streams. This entire sentence becomes the user message. Notice the naming. Spring AI calls it a user message. Why? Because modern LLMs don't receive just one string. They receive different kinds of messages. For example, system messages, user messages, assistant messages. Right now, we are only sending a user message. Later in this series, we will learn how system messages make the AI behave like a Java expert, a banking assistant, a doctor, a travel guide. But for now, we are simply saying this is what the user asked. Again, no request has gone to OpenAI yet. We are still building our prompt. Many beginners think user means the application user. Actually, it means this text should be treated as a user message inside the LLM conversation. Everything we have done so far has happened inside our application. Nothing has left our computer. Now comes the exciting part. When Java reaches call method, Spring AI finally communicates with OpenAI. This is where all the things that we have learned in our previous 14 videos happen automatically. Spring AI performs several tasks for us. It converts the prompt into JSON, it adds your API key, it prepares the HTTP headers, it creates an HTTPS post request, it sends that request over the internet to OpenAI. Then it waits for OpenAI to process the prompt. The language model generates a response. OpenAI sends the response back as JSON. Spring AI receives that JSON and converts it into Java objects. All of this happens because of a single method call. Think about how much code we would have to write ourselves if Spring AI didn't exist. We would need an HTTP client, JSON serialization, error handling, authentication, response parsing, and retry logic. Instead, Spring AI hides all of this complexity. When OpenAI sends a response, it doesn't send just plain text. It returns a structured response. Inside that response are many pieces of information. For example, the generated answer, model details, finish reason, token usage, metadata. Most of the time, our application only wants the generated answer. That's exactly what content extracts. Imagine ordering a package online. The delivery box contains the product, invoice, bubble wrap, labels, packing material. You don't keep the packaging, you take out only the product. Similarly, content removes all the extra information and gives us just the AI generated text. If the user asked, explain Spring Boot, then content method returns Spring Boot is a open source framework, etc. etc. That's the value our REST API sends back to the browser. So, which method actually contacted OpenAI? Was it prompt, was it user, or was it call? If your answer is call, you have understood the complete flow. Now let's run our application. Many beginners think that when the application starts, it immediately talks to OpenAI. Actually, it doesn't. Let's understand what happens internally. The first thing Spring Boot does is start the application context. Then it scans all our classes. It finds our controller, our service. Next, it reads the application.properties file. It loads the API key, model name, temperature. Now Spring AI uses these values to create the chat client. Notice something important? Even now, no request has gone to OpenAI. The application is simply getting ready. Think of it like opening a web browser. Opening Chrome doesn't automatically search for Google. Similarly, starting the Spring Boot application doesn't automatically contact OpenAI. The AI is contacted only when a user sends a request. Many developers think the API key is validated during application startup. Actually, OpenAI validates it only when the first request is sent. Our application is running. Now let's test it. We will use Postman because it's one of the easiest tools for testing REST APIs. We are making a post request to our chat endpoint. Inside the request body, we send a JSON object containing the user's question. This JSON is received by our controller. The controller forwards the question to the service. The service uses chat client. Chat client builds the prompt. Call method sends the request to OpenAI. OpenAI generates the answer. Finally, the response comes back to Postman. Notice how many steps happen behind the scenes, even though our code is only a few lines. Can you replace Postman with a React application or an Android app? Absolutely. The backend remains exactly the same, only the client changes. This is one of the biggest strengths of large language models. Notice that our Java code never changes, only the question changes. Let's try a few examples. First, we ask explain Spring Boot. The AI gives a technical explanation. Now we ask, write a Java program to reverse a string. The AI writes code. This is something traditional software couldn't easily do. Normally, we would write separate code paths for every feature. With an LLM, the behavior changes simply by changing the prompt. That's why prompt engineering is so important. We will learn that in our next video. Related to ChatGPT. The ChatGPT website also doesn't have separate buttons. Let's see temperature in action. We will ask the AI exactly the same question 3 times. The question is, write a birthday wish at temperature 0. The answer is very predictable, short, professional, almost no creativity. Now let's increase the temperature. Notice that the wording becomes more natural. Here, when we set the temperature to zero point 0.7, the output is wishing you happiness, success, and lots of joy, which is different from the answer that we got when our temperature was zero point 0. Finally, let's use a high temperature of 1.0. The AI becomes much more creative. The sentences become expressive and long. Sometimes it even uses metaphors or poetic language. Every developer encounters errors while building AI applications. Let's understand the most common ones. The first one is 401 unauthorized. This usually means your API key is incorrect or missing. Double check the key and ensure it's configured correctly. The second issue is 404 or model related error. This often happens if the model name is incorrect or unavailable for your account. Another common error is 4 to 9, too many requests. This means you have exceeded the allowed request rate or your available quota. If you are testing repeatedly, this is something you will eventually see. Finally, remember that network issues can also prevent requests from reaching OpenAI. The important thing is not to panic. Read the error message carefully. It usually tells you exactly what's wrong. If you are preparing for interviews, these are questions you should confidently answer. For example, why shouldn't the front end call OpenAI directly? Because your API key would be exposed to everyone. Why do we use the service layer? To keep business logic separate from request handling. When exactly does the network request happen? During the call method. What does content method return? Only the generated text from the AI response. If you understand these answers, you have built a solid foundation for Spring AI development. Today, you have built your first AI powered Java application. More importantly, you didn't just copy code, you understood what actually happens internally. You now know how a request enters a Spring Boot application, how Chat Client prepares the request, when the network call happens, how OpenAI generates the response, and how the answer comes back to your API. This understanding is very important. See you in next video. Thank you for watching.